Let's take a look at this example. Again, we have the system of two linear equations, and we have to solve this system of two linear equations for x and y. A and b we're supposed to treat like the numbers, okay? So again, we are going to use the method of substitution. So what I'm going to do first, I'm going to copy down, for example, first equation. You can always start from the second one. I'm going to start from the first one. X plus ay is equal b. I'm going to solve this equation for x. I have to move ay to the right side. And I have x equals b minus ay. Okay, this is my temporary x. Why I'm saying temporary? Because this x contains y. That's why I call this temporary. My final expression for x doesn't supposed to contain y. That's why I call this temporary. Okay, so what I'm going to do next, like always, because I use the first equation to find this x, I'm going to use the second equation to find y. Copy down the second equation. I have x minus by is equal a. This time, instead of x, I'm going to write b minus ay, because x is equal so. So I have b minus ay minus by is equal a. Now, I'm going to move this b to the right side. Why I'm moving that? Because this b is not multiplied to y. Okay? I want to keep all terms which contain y on the left side, and everything without y I'm going to move to the right side. So I have negative ay minus by is equal a minus b. I'm doing everything step by step. Next, please notice that we have y in these two terms. What am I supposed to do next? I'm going to factorize y, okay? And I'm going to also factorize the negative sign. So I'm going to have common factor negative y. And inside of the parentheses, I have a plus b equals a minus b. Next, we're supposed to find value of y. Okay, so I have to divide both sides of this equation by whatever is multiplied to y. I have to divide both sides by negative a plus b. Negative a plus b. So a plus b and a plus b will cancel out. Negative sign and negative sign will cancel out. And I have y equals, and I have, imagine that like I have invisible parentheses, and I have invisible positive sign divided by negative gives me negative. And in the numerator I have a minus b, and in the denominator I have a plus b. In order to eliminate this negative sign, I can multiply this sign by the numerator or by the denominator. But I'm going to multiply by the numerator because I have negative sign between a and b. So negative times invisible positive is going to give me negative, and negative times negative will give me positive. That's why my numerator is going to look like this: b minus a over a plus b. So I can write that y is equal b minus a and a plus b. Okay, so this is my y, but you're supposed to keep in mind that denominator cannot be 0. So supposed to write also on the side that a plus b supposed to be different than 0. Okay, so we finished with y. Next, we're supposed to find x. I'm going to use this equation this time. I'm going to copy this down. And I have x equals b minus ay. Y I have to substitute by this fraction. So I have x equals b minus a, and I have fraction b minus a over a plus b. Okay. Next, we're supposed to perform the multiplication. So I have x is equal b minus, and I have a times b is going to give me ab. A times negative a gives me negative a squared over a plus b. Next, I'm supposed to find the common denominator because I have fraction over here. Common denominator is going to be a plus b. So I have b, and I have a plus b over a plus b minus a b minus a squared over a plus b. Next, I'm supposed to perform the multiplication, and I'm going to have x equals ba plus b squared minus ab plus a squared. Everything is over a plus b. Please notice that I have positive BA and negative AB. Okay? AB and BA, this is the same thing. So that's why these two terms are going to subtract each other. And I'm going to end up with a squared plus b squared. I have a squared plus b squared over a plus b. Okay, so I can say that x is equal a squared plus b squared over a plus b. Okay, so this is the expression which represents my x, and this is the expression which represents my y. In order to verify the answer, we're supposed to plug in these two fractions into the original equation and check if the left side of my equations is going to be equal to the right side. So now let's prove that our answers are correct. Keep in mind that the denominator cannot be 0. That's why I wrote that a plus b cannot be equal 0. So instead of x in the first equation, I'm going to write a squared plus b squared over a plus b. But let me copy down the first equation anyway. And I have a squared plus b squared over a plus b plus a times y. And instead of y, I'm going to write b minus a over a plus b equals b. I'm going to copy down first fraction. I have a squared plus b squared over a plus b. Next, I'm supposed to perform the multiplication. A times b is ab. A times negative a is negative a squared over a plus b has to be equal b. Please notice that we have common denominator already. That's why I'm going to simply write a squared plus b squared plus ab minus a square over a plus b. Okay, this is going to be equal. Okay, I have a plus b in the denominator, and I have a square and I have negative a square. Okay, these two terms are going to subtract each other, and I'm going to have b squared plus ab. I can factorize b from these two terms. That's why I'm going to have b, and inside of the parentheses I'm going to have b plus a. Okay. Now, please notice that we have in the denominator a plus b, and in the numerator b plus a. This is basically the same term. That's why I'm going to cancel this out. Why? Because I have also multiplication over here. Okay, if I have multiplication, I can cancel these two terms out, and I'm going to end up with b. My first equation is equal to b. So I proved that the left side of my equation is equal to the right side because I got b over here. Let's take a look at the second equation. I have x minus by is equal a. Instead of x, I'm going to write a squared plus b squared over a plus b minus b times y, and my y is equal to b minus a over a plus b, and this has to be equal a. Copy down first fraction. I have a squared plus b squared over a plus b, and I have minus b times b gives me b squared. B times negative a is negative a b, we can say, or ba, over a plus b. Has to be equal a. Now we have a squared plus b squared over a plus b. Okay, right now we are going to perform the subtraction. We can add the parentheses over here. Remember, anytime we have negative sign at the front of the polynomial, we're supposed to simply change every single sign inside of the polynomial. Okay, so I have to change this invisible positive to the negative, so I'm going to have negative b squared. Negative times negative will give me positive ba. Now let's take a look what we have got. B squared, and I have negative b squared. These two terms are going to subtract each other. I can factorize a from these two terms, and I'm going to have a, and inside of the parentheses I'm going to have a plus b, and in the denominator I have a plus b. A plus b and a plus b will cancel out, and I end up with a. Please notice that on the right side of my second equation I have a. So we just proved that the left side of the equation is equal to the right side. So we can say that the ordered pair of x equals a squared plus b squared over a plus b, and y equals b minus a over a plus b is the solution to this system of two linear equations.